Welcome to this video. In this video, we are going to talk about RSA algorithm. Although RSA algorithm is very hard to crack, you might be given some challenges to crack weak RSA algorithm, and it is very important for you to understand and implement this algorithm by yourself, because as an ethical hacker too, you need to come across this algorithm often. So you need to have a basic understanding about RSA algorithm. So first of all, RSA algorithm is a asymmetric cryptography algorithm. So what is asymmetric? There is a two thing. One is a symmetric algorithm and another is asymmetric algorithm. So asymmetric actually means it work on two different keys. There is a public and private key. So there is a two key in asymmetric and there is only single key in symmetric. So that means this is a composite key. So that means a message can be encrypted by private key and decrypted by public key, or vice versa. You can encrypt by public key, and for the decryption you will use private key. So either use public key for encryption, then so one key cannot be used for both. So public key cannot be used for both encryption and decryption. So another key will be required for the next operation. So as the name describes, the public key is given to everyone and the private key is kept private. So the example of asymmetric cryptography is a client sends its public key to the server and requests some data. And the server encrypts the data using client public key and sends the encrypted data. Now the client receives the data and decrypt it because it has the private key. So client has the private key for the decryption. So this is the RSA algorithm. Let us see the example, the algorithm of RSA. It is very simple if you understand, but here you can also see some complex math. You do not need to go in detail, but you need to have a basic understanding why RSA algorithm is so powerful and widely used algorithm. So for the algorithm part, let us take a simple example. So first of all, we suppose two prime numbers, P and Q. Now in practice, this will be very large number, maybe 512 bits, 1024 bits and so on. So very large number. Because if this P and Q is known, then RSA algorithm can be easily cracked. So the weakness of RSA algorithm depends upon the value of P and Q. If the value of P and Q is very large, it is near to impossible to crack this algorithm. So for example, we just take a simple digit which is 53 and 59, which is very weakest algorithm obviously, because you can see P and Q is very small. Now we basically compute the public key by just multiplying them, P and Q. So N is our public key. Now we got the public key. Now after getting N, the next step is to find Euler's tangent coefficient, which is simply P minus Q times Q minus 1. So P minus 1 times Q minus 1 gives us Euler's tangent coefficient, which is in our case 3016. Because P is known, Q is known, P minus 1 will be known, Q minus 1 will be known. We multiply them and we got Euler's tangent coefficient. So after getting this phi of N, we also need to get this small exponent E, which must be an integer, but this should not be the factor of phi of N. This is the important one. So we also need to consider the value of E, and it should not be the factor of phi N, because if you find the factor of N, which is P and Q, then Euler's tangent coefficient will be known, and obviously all the things will be known. So the main advantage of RSA algorithm is it is very hard to factor the value N, because this N will be very large. Because remember, we are taking P and Q value that is very large, and to just multiply the value of P and Q, now N will be very large. If the value of N is very large, we cannot factor the n. So we cannot factor means we cannot find the value of p and q. So that is the reason the RSA algorithm is very strong. That is the we cannot factor the value of n. Now if the value of n is very small, we can easily crack this algorithm. Now after finding the value of phi of n, which is tocent coefficient, we also consider the value of e, which is a random integer you need to consider, but you need to make sure that random integer is not a factor of phi n, this phi n, and it also should be within the value of 1 to phi n. Now after you find the value of n and e, so combination of value of n and e is our public key. Now you need to calculate private key, because now we have a public key. Now private key, let us consider the name d for it. So now d can be computed by computing this k. So k can be any value, which is just used for the forward substitution. And phi n is this tocent coefficient that we calculated, and divide it by e, which is our integer or exponent. Now using this we find the private key. In our example it is 2011. Now we have a public key, which is this. You can see the combination of n and e is our public key. N is this p times q, e is what we consider using this criteria. We also have now private key, which we computed right here. Now using this private and public key, we can encrypt the message high now. So h is value 8, because we need to convert this letter into the numbers. I is at the position 9. Now we have this encrypted data. So 89, so 89 is our message. The original message is 89 because high is 89. So 89 power e, which is exponent mode of n, gives us the value c. What is c? C is a cipher text here. C is not anything but a cipher text, which is encrypted text. So high has been encrypted into this c, which is 1394. So 89 is the original message. This has been encrypted with 1394. Now let us decrypt this. So 1394 is now decrypted by taking this private key, which is d. Now d is our private key. So to decrypt the data, we take that ciphertext power d, which is private key, and mod n again, and we get the decrypted data, which comes out to be 89, obviously, because 89 is what our original message was. So to encrypt and decrypt, we use these two things: the value of n, which is our public key, the value e, which is our exponent, and the value d, which is our private key. To compute this private and public key, the main focus is on the value of p and q, because if the p and q is known, n will be known. If n is known, we can get all the things, because if n is known, if p and q is known, we can find Euler tocent. If Euler tocent is known, obviously we can find the value d, which is a private key. So that means if you know the value of p and q, you can compute private key. That is a dangerous part here. And if the private key is known, then obviously we can decrypt the original message. So that is the reason we need to make sure that this p and q, which is the two prime numbers, should be very large so that no one can find the factor of it.